And so here I have an interesting example of a parametric equation. I've got an x equals 3t squared and y equals t plus 2, and I've got t ranging from -2 to infinity. All right, so one of these functions is quadratic in nature, the other is linear in nature. That does give me some idea that perhaps this graph is going to be a parabola or something curved anyway because of the square in there. So what I want to do is I want to graph this curve, those parametric equations are given, and show its orientation. So I want to plot the graph, I want to put arrows on to represent which way the graph is going to be progressing as t increases. I also want to find the rectangular equation and verify using a graphing utility. Okay, so I want to find the rectangular form of this. And I want to plot it on my calculator, which is kind of interesting. We'll be able to do that in just a few minutes as well. Okay, so the first thing I want to do is plot the graph. I think a very simple way to do this is to plot, an XY table, try to get some values figured out. Now notice my t-values run off to infinity, so I'm not going to be able to get an endpoint on the upper end of this for my t-values, but I can get a good idea of what this graph will look like. Let's go with t, x, and y. At least can get a start, and then we'll kind of use some patterns and maybe identify some things that we know to get the rest of this graph. So t, let's start at -2. Let's go with its lower value. Let's go with -1 and 0. That gets us some points that we can easily calculate using some nice arithmetic. And then I don't know, I don't want to, maybe I just want to do, maybe we'll do 1 and 2, and maybe we'll do like 4, 6, and 10 or something, just to get, obviously I'm skipping a bunch of numbers in there, but just to get an idea of where this is going to go as t continues to increase. And I'm just picking out some numbers I think might work nice. They may not, we'll see. Or I may find that the coordinates are not numbers that I really want to plot, so I don't need some of these, so we'll see. Plug in -2. First of all, for x, -2 squared is 4, 4 times 3 is 12. So it's going to be 12. The y value, actually, let's go ahead and just do all the x values first. Kind of like that, I don't have to rethink which function I'm on and everything. I'm just going to stick with this function. So -2, -1 squared is 1 times 3 is 3. 0 squared is 0 times 3 is 0. 1 squared is 1 times 3 is 3. 2 squared is 4 times 3 is 12. 4 squared is 16 times 3 is 48. I already can tell I'm not going to like the rest of these. 6 squared is 36 times 3 is 108. And then 10 squared is 100 times 3 is 300. I'm definitely not plotting these last few points. I don't want to plot out to an x value of 300. I may just stop at the 2 there. We'll see. Anyway, the y values, let's go with those. So -2 plus 2 is 0. -1 plus 2 is 1. 0 plus 2 is 2. 1 plus 2 is 3. 2 plus 2 is 4. 4 plus 2 is 6. 6 plus 2 is 8. 10 plus 2 is 12. All right, those are the corresponding y values. All right, so if I go ahead and plot this again, maybe I'll chop it off right here. Maybe I won't use those bottom 3, but we'll be able to tell from the pattern that those 3 are still on the graph. We'll see. What else is important? Something that's important here is that my y-intercept is at 0, 2, and my x-intercept is at 12, 0. Those are kind of interesting points, and often x and y-intercepts are good points to find if you can. To find a y-intercept, just as a general principle, to find a y-intercept, you're going to let, you're actually going to, the y-intercept is here, you're going to let x equal 0, you're going to solve for t, right? So you would let x equal 0, you would solve for t in this equation, and then you would replace, you'd find whatever value you find for t, you would put in for y. So then put that t in the y equation, and solve for y. Okay, so that's how you would find a y-intercept if I didn't already have it up here. Okay, may not always get that point. And then to find an x-intercept, just do the opposite, right? You let y equals 0, solve for t, put that in the x equation, and solve for x. Okay, so it would just be the opposite variable if I was doing the x-intercept. So anyway, I'm not going to go through all that, but that's sort of your process if you were asked to do so, or if you needed to find those points to plot the graph. All right, so let's go ahead and plot these individually now. I know my x values range from 0 to 12 and then really get big, so maybe I'll stop at 12 or 20, somewhere in there. The y values are all positive. I don't have any negative here, so except for, well, 0, I don't know if that's not positive, but it's also not negative. So we're going to go above the x-axis and to the right. So mostly, yeah, pretty much all first quadrant and a couple axes. So that helps in determining what part of the graph I want to use, mostly first quadrant. Again, let's go to the right. Maybe we'll put up here, there goes 16. That's a nice multiple of 4, which allows me to cut things in half. We'll put 12 there. That's 8. That's 4. That one's 12, 14, 10, 6, 2, and then I'll put my odd numbers in. Okay, so there's up to 16. And then vertically, I just need to get up to 4, maybe up a little bit higher than that. Maybe I'll go up to 8, and then we'll get all the way up to 12 there. 4, 2, 6, 7, 5, 3, and 1. All right, so there's a decent scale. And then I want to plot this. So my order pairs 12, 0 is going to be right here on the x-axis. 3, 1, I go over 3 and up 1. Not too bad. 0, 2, so over 0 up 2, that's my y-intercept. That's 8, right? Okay. 3, 3, so over 3 up 3. And then 12, 4, so over 12 up to 4. All right. So that gives me 5 points. And then, of course, 48, 6. So if I were to go up to 6, that'd be way out there at 48 and so on. Then it kind of shoots out to the right. Now, the orientation of this graph, how do I plot this? I start at 12, 0 and work my way around kind of left and then right. Okay, so start here at 12. Kind of work my way around. And then shoot off to the right. That looks pretty good. Not too bad. It's a little bit wobbly there at the beginning, but there, not too bad. Now what does that graph look like? Probably looks like a parabola, right? In fact, it is a parabola. However, it's not the entire parabola. It stops here at 12, 0. It doesn't shoot all the way through like a normal parabola would. So that's interesting. It has a starting point and then doesn't have an ending point. Now the orientation for this graph is going to be kind of starting at the bottom here and working its way upward, because that's the direction of the graph as t increases from -2 to infinity. So my orientation, I put my arrows in, kind of going lower right to upper left and then back to the upper right area. No, it doesn't matter how many arrows I put in here really. I just need to make sure there's enough to make it clear what the direction is of travel of that graph. Okay. All right, so that gives me the orientation. What else do I need to find here? Got the graph, I've got the orientation. Find the rectangular equation. Okay, let's do that. So I'm going to get rid of this. All right, so I got rid of that. What I need now is to look at these two equations, and it's going to be a lot easier to solve for t in this equation, the y equation, than it is for the x, just because of the square on the x. So I'm going to go ahead and do that. I like to pick the one that's easiest to solve for. If I can, I'll do the x first because it makes the function notation work better, but this may not actually be a function. So, well, in fact, I know it isn't. In terms of, y is not a function of x in this case. And so it doesn't really matter if I, try to get y as a function of x, because it's not going to work out well that way anyway. So what I'm going to do is I'm going to solve for t in this y equation, and then I'm going to replace the t in the x equation with that result. So I'm going to start with y equals t plus 2. I'm going to subtract off the 2, so t is equal to y minus 2. All right? I also switch the order of the equation around. Then I'm going to take y minus 2, plug it in for the t in the other equation. So x equals 3 times y minus 2 squared. Well, that kind of makes sense. This is a graph of a parabola opening in the x direction, because the y is the one that's squared. And it's also shifted up 2, which makes sense. That gives us a y minus 2, so it's shifted up 2, or has a vertex at 0, 2. And I could leave it in this form, or I could expand it. It doesn't really matter. You know, if I expanded this out, I'd get 3 times y squared minus 4y plus 4, which is 3y squared minus 12y plus 12. Either form is fine. I won't be too picky, but I kind of like this first one just because it shows me the transformation. It's more in line with the form, the rectangular form of a parabola that we saw when we studied conic sections. Okay, so I kind of like that better anyway. Now I also need to put restrictions on my y value or my x value or my domain. Somehow I need to get some restriction on here because I know the t values range from -2 to infinity. That means I can't go beyond this point here, this x-intercept. I can't keep going. The parabola that I just defined here, you know, has an infinite number of points going past the x-intercept to the right, so I don't want those points. So really all I need is to define or to restrict my y values. My y values range from 0 to infinity. My x values, they range from 0 to infinity, but saying the x values go from 0 to infinity would also include those points going out to the right. So really it's the y that is the more restrictive variable here. So I would say where, let's see, 0 is less than or equal to y is less than or equal, oh no, less than infinity. Did I put less than or equal? I did. I am having a hard time with these inequalities here. You can't equal infinity, it's silly. Okay, that works. We don't want to do that. So -2 is less than or equal to t is less than infinity. Good thing I caught that at some point. Anyway, so where 0, let's see. Yeah, y is restricted from 0 to infinity. That makes sense. Okay, so it is a parabola. Now, let's verify this using a graphing utility. So how can I do that? Well, first of all, this is not even a function. So if I go to my calculator, and if I just go to my normal y equals, I can't even put this in, right? If I go to y equals, I don't have a nice way to represent this. I can, however, change my mode to parametric mode. If you hit the mode button, it will give you some options here. And one of the options is function, parametric, polar, and sequence. And what we want is parametric. So we go over to parametric, hit enter, or hit, oh, where is it? Enter. There it is. So now that's highlighted. And now if I go to my y equals, I have a very different looking y equals screen. I have x and y. So I have x1, y1, x2, y2. So I'm going to be typing these in combination. So my x1, I'm going to type in 3t squared. Now the t is actually this x variable button. If you hit that in parametric mode, it will automatically put a t in there instead of an x. In fact, the variable here is listed by the mode. So the x stands for function, the t is for parametric, theta is for polar, and the n is for the sequence. So we want the t. And then we square that. And then I go down and do t plus 2. So I'm just going to type in the variable t, and then the plus, and then the 2. There it is. Now, if I were to plot this as is, you know, I'm going to get, if I go to Zoom Standard or something, it's going to give me a bad window. I want this particular window. So I want my x values to range roughly from 0 to 16. Maybe I'll give a little bit of buffer there. Maybe we'll go like -2 to 20 or something like that. So what I want to do is hit window. Now under window, it's going to actually ask me for the t min and max. I don't know what all these numbers are. They're from some old problem probably. T min and max, X min and max, Y min and max, and then it's got some other stuff in here. Let's go through these one at a time. The T min and max, I'm actually going to use this stuff here. I'm going to go with -2. Now for the maximum, can I use infinity? That is the question. Or do I just have to throw a really big number in there? And the answer is no. There is no infinity on the calculator, at least not that I can find. Maybe I'm missing it, but it's not there. Anyway, what I'm going to end up doing is just putting a T max. It's basically a big number. I'll just put 100 on there. Anything that's bigger than what's going to be needed, anything bigger than, actually anything bigger than 2 would work. I just need to get this graph, and as soon as I get up to 4, I get points off the graph. But I'll put 100 on there just so, well, actually that might be too big. Let's do a 10. Yeah, I did up to 10. That'll work. So I got -2 to 10. Now the t-step, is that what that is? Yeah. T-step is kind of interesting. Basically, the t-step is the interval at which it's going to plot points. The calculator is literally doing this process to plot the points. And the step is the increase in the t-value. So if I say the t-step to be 1, for instance, if I did a 1 there, t-step is 1, that's exactly what I have here. It's an increase of 1, a step of 1. I don't like 1, it's too choppy. What that will end up doing is it will just connect these points with lines that look like a bunch of lines, V shapes and stuff like that. I don't like that. I would actually go with like 0.1 maybe. Oops. So I'll do a t-step of 0.1. That's actually going to plot essentially 10 points between each of the points that I've plotted. So it'll put 10 points in here. It'll connect them all with straight lines, but it'll look pretty curved just because of the number of little segments in between. The smaller we make that number, the nicer the curve will be. So you could do 0.01, but the problem is it takes the calculator a long time to plot those out if you put too many in there. So you don't really want to go with 0.01. It'll take forever to get that. It could be 10 minutes or 20 minutes to get all those points plotted out. So I'll leave it at 0.1. The X minimum, I want to go with -2. The X maximum, I'll go 20 just to get a little bit of extra there. X scale of 1 is fine. Y minimum, I'll go with -2 also. Up to, I don't know, maybe we'll go up to like 6 with a scale of 1. All right, so I'll show you my window then. Final call here, -2 to 10 with a 0.1 step, -2 to 20 with a 1 scale, -2 to 6 with a 1 scale. All right, and when I hit graph, oh, that went too fast. I didn't want you to see that. Okay, let's do this. It's probably going to plot it. They did. Well, when you hit graph, you guys will see it if you're doing this. It'll just plot that right out in the direction of the orientation too, which is kind of nice. So that's a pretty good graph. It looks almost identical to the one we have up here on the board. So that's good to see. Now it is kind of choppy. As I'm looking at this graph, you can tell it's not really smooth. It's definitely kind of choppy. If I increase the t-value, t-step, sorry, maybe to like, I don't know, 0.01. Let's do 0.01. Let's see what happens if I do 0.01. You'll see that it actually plots out very nicely. That's not too bad. Cool. That was pretty smooth, and it actually didn't take that long to do. So I'm not too disappointed with that. And then I could always change that maybe to, if I wanted to do just 1, a t-step of 1, you can see that really is boxy there. So we don't really want to do that. Too many corners, okay? So anyway, that does give us a pretty good idea of how to, plot the graph, find the rectangular equation, plot the orientation, and use a graphing utility.